So can you tell me what was the first graph?
Displacement time graph, sir.
Yeah, displacement time graph. And how was the displacement time graph?
Straight line, sir.
Straight line parallel to
Parallel.
time axis, correct?
Correct, sir.
Yes. So what does this mean, Samuel?
Uniform motion, sir. Was what I wrote.
No. So this signifies that body is at rest. Okay. Why is it so? What is the displacement value here? Whatever it is, let's say it is a constant, correct?
Right.
Let's say it is 5 meters, for example. What is the value here?
Also 5 meters.
Yes. What about here?
5 meters.
So although the time is changing, right? Time is changing, right?
Right.
But where the particle is, that position is not changing, correct?
Yes, sir.
Therefore, the body is not moving with respect to time. Therefore, it is at rest.
Yes.
Clear?
Yes, sir.
Okay. What was the second graph?
Velocity time.
Velocity time graph. And how was the graph? Was it like this?
No, sir.
Okay. Like this?
No, sir.
Okay. Like this?
Yes, sir. This is.
That's fine. That's fine. I mean, it doesn't matter whether it is where it is starting. So let's say here. Okay, it's same as, I mean, I have just shifted the time, right? That's not, does not matter. So if you see, so what kind of motion is this? Is the body at rest? Is the body in uniform motion? Is it in non-uniform motion? This was the question, right, Samuel?
Yes, sir.
Yeah. So what can you infer from the graph?
So it's in uniform motion.
How do you say that?
It's traveling with constant velocity.
See here. So what is the body in? The correct answer is non-uniform motion. And specifically what we will see now. See here, what is non-uniform motion? When a body does not move with constant velocity.
Right.
It is opposite of what you said, right? So here if you see, the body is actually not moving with constant velocity. Why? Because what is the velocity here? How much is the velocity here? How much is the height here? Which point is this? Isn't it the origin?
Yes, sir.
Yeah. So what is the height here? What is the height in the y-axis? Tell me, man. What is this height? What is this point?
Origin.
Origin, right? So that means x is 0, y is 0, correct?
Right.
So when time t is 0, what is v?
Also 0.
0, right? Okay. What about v here?
0.
Is it 0 then?
Wait, wait, wait.
Is there not a height? Is it 0?
No.
No, right? It is probably some number. Let's say it is 5. What is it here? It is more than that, correct or not?
Yes, sir.
So is the velocity changing or not?
Yes.
Understood?
Yes, sir.
So once the velocity is changing, what can you say about the motion?
It's a non-uniform motion.
Non-uniform motion is correct, right? Okay. And in non-uniform motion, you have two categories, right? What are they?
Uniform accelerated motion and non-uniform accelerated motion.
Exactly, exactly. So among the two, which one would it be? See, for which you will have to relate to what you have learned in straight lines. See, usually when we draw a straight line, right? We call this line as y is equal to mx plus c. You not just learn it in straight lines, but also use it in physics, chemistry, everywhere. Usually a straight line is represented by the equation. What is it?
Y equals to mx plus c.
Yes, y is equal to mx plus c, where m refers to the slope of the line and c refers to what we call as y-intercept. That means where the line meets the y-axis. Okay. So if you see, so this is a line which is of this form, correct? So I can associate some y is equal to mx plus c to this, correct?
Correct, sir.
So here y is velocity. And what is x? What is on the x-axis?
X is time.
Time, right? So mt plus c. Got it?
Right.
So if I give you an equation, velocity is equal to say 5t plus 4. Now can you tell me whether it is, what kind of motion is this?
So once you differentiate it, you get 9.
Sorry, you
5
get?
actually. 5 actually. 5.
Correct. So what can you say? What can you say about this motion?
It's in uniform motion.
Sorry? Come again. Just tell me, Samuel. Yeah, I gave you v is equal to 5t plus 4. You differentiated and got a as 5. So what does that mean? What kind of motion is this? What is your acceleration?
That acceleration is non-uniform. Accelerated movement.
You didn't revise that? The non-uniform motion is divided into what categories? Tell me.
Uniform accelerated motion, non-uniform accelerated motion.
Right? When do you say a motion is uniform accelerated?
So when acceleration is equal to a constant but not 0.
Correct. So what are you getting here in this question?
Constant.
Constant which is not 0, right?
Right.
So what motion should it be?
Uniform accelerating.
Don't say uniform. Uniform accelerated motion. Correct?
Uniform accelerating.
Yeah, that's correct. So it is uniform accelerated motion. All right. But this equation is not given to you, but you should know whenever an inclined line is there, it is of the form y is equal to mx plus c. So here y is v and x is t. So it is of the form v is equal to mt plus c. I just took an example 5t plus 4. M and c are constants, right? So you should treat them like that. So when you differentiate velocity, you get acceleration, you get 5, which is a constant. When acceleration is constant, what kind of a motion is this?
Uniform accelerated motion.
Correct. Very good. Is it clear to you now?
Now what is it?
Yes, good. Okay. Okay, what was the third graph?
Acceleration time graph. Straight line parallel to x-axis.
Like this, right?
Yes, sir.
Yes. Yeah, tell me now. What is this motion and why?
So the object is moving with constant acceleration.
Very good.
So the body is at rest.
Body is at rest. You said with your own, in your own words, you said body is moving with a
Acceleration is
constant acceleration. Huh?
right.
If it's moving with a constant acceleration, can it be at rest?
No.
Tell me whatever you want.
Uniform motion.
Not uniform. When acceleration is 0, that is when it is uniform motion. What is my uniform motion?
When acceleration is equal to 0 and velocity equals to 0.
Velocity is equal to 0. If velocity is 0, body is not moving. Body is at rest. What is uniform motion?
Where velocity won't change.
Yeah, velocity won't change. And velocity is a
Constant.
constant, not 0, right?
Right.
When velocity is constant, then acceleration will be
0.
0. That is uniform motion, right? So is this uniform motion?
No.
So what is it?
Non-uniform.
Non-uniform motion. In non-uniform motion, what is it?
Uniform accelerated motion.
How do you say that?
Because acceleration is equal to constant. It's not
Yeah.
0.
It's not 0. How do you say it is constant? From the graph?
So because like for example, we can take any object to be moving with 7 meter per second. At one point it moves at 7 meter per second.
No. From the graph. From this graph, tell me. From this particular graph, how do you say it is uniform accelerated motion? What makes you say acceleration is constant? Now go ahead, explain. Very simple. See here. Look here. All that you need to say is what? Sir, let's say this is point A, this is point B, this is point C. 3 different times I'm taking. T1, T2, T3. At all these times, what is the value of acceleration?
What's that?
You're not listening? Sir, how do you establish? I'm asking you, how do you establish it is uniform accelerated motion? How should you say that? How do you, from the graph, determine that acceleration is constant? Say at time t1, what is the acceleration?
8.
What is the height?
Time t1, time is t1.
Time is t1. At that time, what is the height? Height refers to the acceleration value, correct?
Yeah.
So let's say it is 5 meter per second square. What is it at time t2?
Also the same thing.
All the same. Time t3.
Same thing.
Exactly. Is that clear? So that's how you establish that acceleration is not changing with time, correct?
Right.
Hence it is constant. Because acceleration is constant, it is uniform accelerated motion. So what is the answer?
Uniform accelerated motion.
Yes. Yes, Samuel?
Yes.
Is it clear? Yeah, okay. What was the fourth graph?
Acceleration versus time. Same thing as
Acceleration.
second one.
Is it like this?
Yes.
Okay, tell me.
So we can apply straight lines concept over here.
Correct, good.
And you get A equals to MT plus C.
Yes, A is equal to MT plus. Very good. Tell me what kind of motion is this? So you did all the work that is necessary is done in this question. Now all that you have to do is you just analyze.
Right.
Tell me. Just a second is enough to analyze and give the answer. Yeah, go ahead.
Non-uniform motion.
Non-uniform motion is okay. In non-uniform what? Be specific.
Non-uniform accelerated motion.
Yes. So it is non-uniform accelerated motion. Why do you say so?
So because your acceleration is not constant, it changes with time.
Very good. That's all. So are you clear with this?
Yes, sir. Just write it down.
Yeah, please. So you did the important work of relating this, right? A is equal to mt plus c.
Right.
So that itself completes the answer because it clearly shows that acceleration depends on time. So if time changes, acceleration also changes. Hence it is non-uniform accelerated motion. Good. Last. Fifth one. I had given you 5 graphs, right? Or
7,
more?
sir.
7 I had given. Good. Okay. So let me move on to fifth one. Yeah. What is fifth one, Samuel?
Displacement time.
Displacement time, and how is it?
It's curved.
Curved, is it? Okay.
Yeah, like that.
What do you understand from this? Okay, in your conic sections, what is this conic?
Parabola.
Yes. Isn't it a parabola? You don't
Yeah.
go to the left side of it. This part is not visible because you don't take negative time, correct?
Yes, sir.
That's the reason you only have it in the first quadrant.
Okay.
So you should understand it is a parabola, correct?
Yes.
Yeah. Now, do you remember the equation of the parabola? Suppose if I draw a parabola like this. Can you tell me what would be the equation of this parabola?
Equation of this parabola would be x-axis.
No.
So like the equation of this parabola.
Yes. Like you have an equation, if a straight line is there, we told that equation of a straight line y is equal to mx plus, right? Like that for a parabola, what is the equation?
In the forms.
You have 4 forms, right?
Yeah, there are x squared is equal to 4ay, x squared equals to minus 4ay, y squared equals to 4ax, y squared equals to minus 4ax.
Very good, very good. Of those 4, which one does this represent?
Y squared equals to 4ax.
Are you sure?
Yes.
Y square equal to 4ax is a parabola open to the right. This is the parabola y square equal to 4ax. The parabola open to the left is y square equal to minus 4ax. The parabola open to the top is x square equal to 4ay. The parabola open down is x square equal to
Minus 4ay.
Got it? So of these 4, which one does this represent? It does not represent y square equal to 4ax. It represents
X squared is 4ay.
x square is equal to 4ay. All right. So what is x square here? What is in place of x here?
T.
Okay. What is in place of y?
S.
So what is the equation?
T squared is equal to 4as.
Or in other words, S is equal to T square by
4a.
correct. Or I can write it as S is equal to some constant into T square. Got it.
Right.
Now tell me from this. What kind of motion is this? Constant, you can take it as 5, 4, whatever, just for your for getting to a decision on what motion does this represent.
There's a non-uniform motion.
If so, tell me why, and then if so, then tell me specifically what kind of non-uniform motion is it. If not, why not? So all that you should say.
So there's a uniform accelerated motion.
How do you say that?
So because here S is constant.
Is
Equal
S a constant?
K.
K is a constant, ma. Say K is some constant 5, whatever. Tell me now.
Hmm.
No, because you giving different answers is not important. Whatever answer you give, you need to give me right justification for that. Because we all know that it's going to be one of the three, right?
Yes.
Yeah. So I want you to clearly tell me why, what is so. S is equal to 5t square. So what is happening? I don't want just the answer, I want the explanation why it is so. Go ahead, tell me, ma. Because the moment you say, is it, right? Is it this motion or that motion, that itself says, you're not sure, correct? But you have all information that is required to get the answer right and give the right explanation. There's no new concept required now. Go ahead, tell me, ma. Yeah, what is your analysis? Go ahead. This requires a few seconds to get it. So the harder job is already done. Converting the graph to equation is already done. Yes, Sam. What do you do with the equation? We have done this yesterday, right?
Differentiate.
If you differentiate, what do you get?
10t.
What is that called? If you differentiate displacement, you get velocity, right?
Yes.
So velocity is, what can you say? V is equal to 10t. What does that mean?
Which means velocity isn't constant.
Velocity is not a constant, correct? Velocity is no, because it depends on.
Because it on what's that?
No. Why is it not a constant? How do you say that? What makes you say that?
Depends on time.
Yes, very good. So it depends on time. So velocity is not a constant because it depends on time. If it depends on time, what kind of motion is that?
Non-uniform motion.
Yes, it is non-uniform motion. Now at this point, you're only able to say whether it's uniform or non-uniform. Now we need to go one step further. So you differentiate again. So what do you get?
10.
10. And what is this?
Uniform accelerated motion.
Yes, because your A is a constant, correct?
Yes.
So it is non-uniform motion. In non-uniform motion, it is uniform accelerated motion. That's all. Is it clear to you?
Yes.
So there are just first thing is the graph you identified is a parabola, and parabola
Yeah.
how is the relation? It is y related to x square.
Yes.
So it is s is equal to some constant into x square. That is t square here. Then everything is done, right? The moment you get the equation, it's not a new question. It's what we did last class. Is it clear?
Yes.
Yes. We move on to the next question. What is the next question?
Velocity time graph. Curved.
Yeah, you have velocity, time graph, and how is the graph?
It's curved. Yeah, like this.
Parabola. Right? Yes. Go ahead. Now tell me.
So the form is again in x squared equals to 4ay.
Correct.
And t squared is equal to
Go ahead. Correct.
4 into a into v. T squared is 4av.
Okay.
So v is equal to t squared by 4a.
Okay. Yeah. Go ahead. Tell me. Yes, ma'am. You just need 2 seconds to get it. It's done. Already done. Yes, Samuel. Tell me, ma'am. So how is V related to T?
What's it?
How is V related to T?
So because it
No, no, how? I'm not saying. Why? Tell me the equation.
v is equal to t squared by 4a.
4a, no, don't worry, right? They are constants, correct? So how do you write it?
2t. Differentiation is 2.
V square. V is equal to
T squared.
V is equal to T square. You can write or constant, some constant. Maybe 5t square or kt square, whatever, right?
So v is 10t.
Sorry?
Or any constant. Any constant, if you take either 5 and differentiate that, you get 10t.
Differentiate, when you differentiate it, does it stay V?
No.
What does it become? At this point, you can make a decision. What is it? What kind of motion is this? Without doing any other step, you can say what motion is this? No, all reference must be here. Yes, Samuel, not in the notes. Very simple, right? Velocity depends on time. So it is what?
Non-uniform motion.
Step 1. At this point, we are unable to decide on further what kind of non-uniform motion. For that, we need to differentiate. So you get A is equal to dv by dt. When you differentiate, k is constant. When you differentiate t square, you get 2t. Don't worry about the 2k, at 2k, right? So a is directly proportional to t. So which means a depends on time, which means a is not a constant.
Right.
If a is not a constant, it changes, which means
Non-uniform accelerated motion.
how much time does it take? Is it clear? Yeah.
Yes. Yes.
Yeah. So there's no doubt in that. Now, only thing is only this is acceptable, right? I mean, graph we were not sure. We found a way to convert it into equation, correct? But once you get to the equation, you need to be like a bullet train. You need to be very fast, correct?
Right, sir.
That will happen when you revise it. I think you've not touched the notes what we discussed last class. I think I'm not doubtful if you've gone through the video too. Yeah. So do it, okay?
Yes, sir.
Yeah, because what happens is within 24 to 48 hours. It's like they say, right, in medical terms. We can say anything after 24 to 48 hours, right? A patient, correct? So it's
Yes.
like that. Your brain is like that. Not just your brain, my brain, everybody's brain is like that. So if you see you're investing some time in, attending the class, you're spending some effort, correct?
Yes.
Expecting to remember it after 1 week. Trust me, you will remember nothing after 1 week if you don't do something. Okay. Within 24 to 48 hours, if you don't revise it, correct, thoroughly, all the effort that we spend, right? Yeah, your parents spend in terms of money and also the time that your mother puts in to sit with you and see that you are fully participating, and the time you are putting yourself, correct?
Yes, sir.
Right, the time that I'm also investing, right? So all of that will go in vain if you don't revise it. Is that clear, Samuel?
Yes, sir.
Yeah, because it will evaporate. It's not rocket science. Just 2 days you give it time, 80% of what I taught is gone without revision. Is that clear?
Right. Right.
But on the other hand, if you revise it on the same day or the next day thoroughly, correct? Then what happens? You will retain it for eternity. You will not forget it.
Yes, sir.
Most of the stuff which I learned 20 years back, I still remember. Not because somebody has a great brain, nothing like that. Because I revised it at that time well. Makes
Right.
sense, Amul?
Yes, sir.
Yeah, so it is extremely important which student miss out is 28 to 48 hours is like gold. You miss that 24 to 48 hours, what the big deal? You has taught me, I'll learn it after 4 days. Gone. Makes sense, Samuel?
Yes, sir.
Yeah, so after class is done, like a ritual, you do, 24 to 40 within that time. You will sit, revise it, redo whatever until you become thorough, correct?
Sure, sir.
Okay, one quote I will tell you, which really impressed me is, it is what you learn after you know it all that counts. It's what you learn after you know it all that counts. Suppose, after class, you know something, yes or no?
Yes.
After that, what you learn will count. Till that, what you learned would not count.
Right.
Makes sense, right?
Yes, sir.
So there is a big difference. When you attend the class, you understand. Correct?
Correct, sir.
But when you practice, that's when you become exam ready.
Yes.
Otherwise, understanding will be of no value because you will forget it in 2 days. Make sense, Samuel?
Yes, sir.
Yes, good, good. Okay, we'll move on. Okay, so we had discussed a few things last class, right? So
Yes,
in
sir.
free motion, we had discussed a few things. Quickly, can you tell me those points? Summarize those points. We learned about dot product. So what is A dot B? What is A
A
cross?
dot B is modulus of A into modulus of B is into cos theta.
Right. What is A cross B?
And modulus A cross B is modulus of A vector into modulus of B vector sin theta. To the
Just
n
sin theta
into
that is
n
also
vector.
in cap. So could you tell me the direction of A cross B?
The modulus of R is equal to root over
No,
A square.
I'm asking you something else. What is
Modulus,
the
sir.
direction
It
of
is the modulus.
what is the
Modulus.
no, what is my question? My question is what is the direction of A cross B?
Y-axis.
No. Who told you Y axis? It all depends on where A and B are, right? If A
Yes.
is along X axis and B is along Y axis, A cross B is not on Y axis. Did I say that A cross B is perpendicular to both A and B? And it is perpendicular to the plane containing A and B? Yes.
Yes.
Yeah. So if A and B are in XZ plane, then A cross B will be on the Y axis. If A and B are on the XY plane, then A cross B will be in the Z axis. So basically what needs to be known is
Perpendicular.
is perpendicular to both A and B. Okay. Yeah. So if I have A vector and B vector, how do I find? A vector plus B vector is represented by what? A vector plus B vector is represented by yes, ma'am. If A vector and B vector, I take it as adjacent sides of a parallelogram. What gives you the vector A plus B? A plus B is called the resultant of the two vectors, represented by R vector. So resultant will be given by, did we not discuss that it is given by the diagonal of the parallelogram?
Yeah.
So diagonal of the parallelogram gives you the resultant of the two vectors.
Yes.
What is the expression for resultant?
Root over a squared plus b squared plus 2ab cos theta.
Right, good. So if the two vectors lie on the same line or same direction, what is the resultant going to be? Case 1, case 2. The two vectors are at right angles to each other. Case 3. The two vectors are in opposite directions. Tell me what will be the resultant. Yes, ma'am. Tell me, ma'am. First one, what is the answer?
So should I apply the formula or just tell the resultant?
Yeah. I mean, at this stage, you should be able to tell the resultant. But if not, if you're not that ready, you can use the formula and then tell me.
Okay.
But just a couple of seconds to answer this question, not more than that. Okay, if two vectors are along the same direction, what is the angle theta? 0. Substitute angle 0 here. Cos 0 is 1. So it becomes a square plus b square plus 2ab, which is a plus b whole square. Root of that becomes a plus b. So resultant becomes equal to just addition of the magnitudes is enough. If two vectors are in the same direction. Should I write it for you or is it clear?
So can you write it, sir?
Write it. R is equal to root of a square, or to be perfect, modulus of a whole square plus modulus of b whole square so when two vectors are in the same direction, the magnitudes may be different, but as long as they are in the same direction, we understand the angle between them is what? 0, because we know that from straight lines, right? If
Yes.
two lines have the same slope, then the angle between them is 0. Yes. So when you substitute theta is equal to 0 here, right? What is cos 0?
1.
So what does this resultant become?
Modulus of a squared plus modulus of b squared plus 2a into modulus of ab.
So what is this? Isn't this a square plus b square plus 2ab?
Yes.
So what is that?
Modulus of a plus modulus of b whole square.
And that within the root. So what would it be? That's all. Correct?
Right.
Is it clear to you? Similar thing you have to do for the other two. Let me know if you noted down.
Yes.
Yes, okay. Second one. How are the vectors? The two vectors are what?
90.
Perpendicular to each other. So theta is
90.
yes. So in the same formula, cos in place of theta I'm substituting 90. What is cos 90? Table.
Cos 90 is 0.
Yes. So because cos 90 is 0, this entire term vanishes. Correct?
Yeah. Modulus of a squared plus b squared.
Yes, that's all. So if you visualize, this becomes a rectangle, right?
Yes.
A parallelogram becomes a rectangle now.
Correct.
And we know the diagonal represents the resultant, right?
Yes.
And that resultant becomes the hypotenuse. And you know hypotenuse is nothing but what?
The
Square of the hypotenuse is nothing but sum
equal to
of
the
the
sum
points
of
of
the
the
other
other
two
two
sides.
sides, correct?
Yes.
So that's tallying with this, correct?
Yes.
And finally, the last one that I asked you. So have you taken this down? You're taking it down?
Yes.
Yeah. Tell me once you're down.
Taken down, sir.
Done? Okay. And the last question that I asked you is third one where A is in one direction, B is in the other direction. And let's say the length of A vector is greater than the length of B vector, let's say. Then what is it going to be, right? The moment they are in the opposite direction, we understand the angle is what?
180.
180 degree. So what happens to your resultant formula?
Cos 1. Substitute 180 in the equation.
Exactly. So what do you get?
So we get modulus of a squared plus modulus of b squared minus 2. Minus 2ab.
Yeah, minus 2. Good. Because cos 180 is
Minus 1.
good. Very good. So when you substitute minus 1 for this, mod a square plus mod b square minus 2ab. What is that?
That
Yes.
is a minus b whole square.
Uh, and there is a root. So what does this become?
R equals to root over a minus b whole square.
Root is, root of a minus a whole square, right?
Yes, the square cancels. So a minus b. A vector minus b vector.
That's all. Nothing else. If modulus of b was greater than a, it will be mod b minus mod a.
Right.
That's all. Those were my questions. Is it clear to you now?
Got it, sir.
So these you should be able to do mentally so that you directly get. The moment I say 180 is a minus b. The moment I say 90, it is root of a square plus b square. The moment I say it is 0, it is a plus b. Is that clear?
Yes, sir.
Yeah. That's the speed you're expected to give the answers at. Is that clear?
Yes, sir.
Yeah. Now I think you're ready. Correct?
Yes, sir.
Okay, good. Then what else did we discuss? So we discussed about projectile motion, correct?
Yes, sir.
So what are the three terms in projectile motion?
Horizontal range, maximum height, and time of flight.
Very good. So there is an initial velocity which you are imparting to the body.
Yes.
And the angle it makes with x-axis is
Theta.
right? Now can you tell me the two components of the initial velocity? What are they?
U sin theta and u cos theta.
Which axis is u cos theta along? Which axis is u sin theta along?
It is along the x-axis.
Which one?
What, sir?
No, which one? Which one along x-axis? Which one along y-axis? Quick.
U cos theta is on x-axis and u
Yes.
sin theta is on y-axis.
Yes, u cos theta on x-axis. We did not go through the derivation of this, but that's also important. I ask you to, learn it. If you did not understand or if you want any aspect to be discussed, please let me know. Okay.
Yes, sir.
Okay, now tell me expressions for different components we had learned. So what is this called?
Horizontal range of the projectile.
And what is this?
Maximum height.
Correct.
Hx.
And what is T?
T represents time of flight.
Total time of flight. So could you tell me the expressions quickly for all the three?
So for the first one, horizontal range is equal to R is equal to u squared sin 2 theta by g.
Very good.
Then second one, H max is equal to u squared sin squared theta by g.
Yes.
And the last one,
Sorry, can you repeat?
u squared sin squared theta by 2g.
Okay.
And time of flight is equal to 2u sin theta by g.
Okay, one more point is the time it takes to go from ground level to the maximum height is same as the time it takes to go from maximum height to ground. So we call it as time of ascent and time of descent. Both those values are equal. So
Right.
total time of flight is what? 2u sin theta by g, correct?
Yes, sir.
What will be the time of flight? The time of ascent.
Right.
The question is, what will be a time of ascent?
The time at which the body takes to get lifted from the ground.
Till what? Till what point?
Till maximum height.
Yes. So what is the value for that? See, very simple, right? Listen. Listen here. From A to C, the total time of flight, if it is 10 seconds, then it takes 5 seconds to climb up, 5 seconds to climb down. Come down. Is that clear?
Yes.
So now tell me. So the total time of flight of the projectile is 2u sin theta by g.
Yeah.
So what is the time of ascent? What is the time of descent? Can you tell me?
Half of that.
Half of that. How much is that? Yes, get it. Quick.
U sin theta by g.
Yes. Time of ascent is equal, time of descent is equal to
U sin theta by g.
2 sin theta by g. Correct. Okay, what is the relationship between range and H max? What is the relationship between range and H max?
R is equal to u squared sine 2 theta cos theta by g.
What is the relationship?
4h cot theta.
Got it. For what angles the ranges, what angles will the ranges be equal? Keeping the
Complementary angles.
complementary angles, correct. So give me example.
Theta and 90 minus theta.
Correct. Fine. Okay. So at what angle is the horizontal range maximum?
For theta is 45.
Theta is 45. Very good. And which component remains constant throughout the projectile motion?
Sine 2 theta equals to 1.
I have
Sir,
moved
in
on
which
to the next
projection?
just still in the same question. I have moved on. I'm asking you a different question now. Listen. Yeah. Which factor remains constant? What is constant in projectile motion? And why? During the entire motion of projectile, something remains constant. What remains constant and why?
Horizontal velocity.
Yeah, it should not be in the notebook. It should be here. Okay. Yes, Samuel, without referring to the note, you should be able to say that. Horizontal component of velocity remains constant. Tell me why.
So because in that case there are three cases which are 0. Force is 0, acceleration is 0, and horizontal velocity is also constant. That's in case of horizontal projectile.
So how do you say that force is 0? Is the projectile experiencing any force or not as it is moving?
It is.
Why it's moving? It is experiencing some force, right?
Yeah.
What force? Then how do you say F is 0? How do you say A is 0? Go ahead. Very simple. See here. Yes, if I ask you a question, is the projectile experiencing force? Yes, it is experiencing force. Is the force 0? No, force is not 0. Is the acceleration 0? Acceleration is not 0. But when we are talking about the horizontal component of velocity, it will only be impacted by the horizontal forces or horizontal acceleration. Are you listening?
Yes.
There is no horizontal force. The force is existing, but that's not in horizontal direction. Which direction it is? It is gravitational force existing in the vertical direction.
Right.
It will only do anything, it will do something to the vertical velocity. It cannot do anything to the horizontal velocity.
Yes.
There is no horizontal force, there is no horizontal act. That's how you should answer and say.
Right.
So there is no horizontal force, there is no horizontal acceleration. Therefore, horizontal velocity remains constant. But does the same thing happen with vertical velocity? No. Vertical velocity is impacted because vertical force is there. There is a gravity
Acceleration.
downward direction, which slows the particle down.
Yes.
Okay. At the topmost point of the projectile, what can you say? For example,
So,
at B, what can you say? Whatever is in the notes must come into your head very soon. By now it must have happened. Anyways,
it will be constant.
oh, sorry?
Constant.
What is constant?
The horizontal velocity.
Horizontal velocity will be constant at all points, not just at B.
Yeah.
Something important happens at that point, unique happens at that point. B, maximum height. Why is this guy not climbing up further?
Due to acceleration due to gravity. Influence on that.
No, acceleration due to gravity is having its influence from at all points in the projectile motion. Why particularly does it stop at B? Why not go beyond B? What happens? What specially happens there? All this we mentioned in the previous class. Vertical velocity becomes 0. Is that clear? At the topmost point B, what becomes 0?
Vertical velocity.
Vertical velocity, because your velocity has two components, horizontal and vertical components. So the vertical component becomes 0. So that's the reason it is not able to climb up beyond. Why does the vertical velocity become 0? Because acceleration due to gravity has been acting for some time now. According to the equation, V is equal to U plus AT.
Right.
As time increases, and acceleration is actually not positive acceleration, it is negative acceleration, because velocity was in the upward direction, acceleration is in the downward direction, so velocity will keep decreasing. And at the point B, the vertical component of the velocity becomes 0. Is that clear, Samuel?
Yes.
And all that is there is only horizontal velocity at that point. Okay, fine. So what you need to do is, you need to also back this up with the derivations, because only then you will understand. If you do the derivation in detail, right, you will understand what are the equations of your initial velocity, your velocity at any given time, acceleration, displacement at any point, because based on all these things you will have numericals. Is that clear?
Yes.
Yeah, not just based on this formula, but the way these formula are derived, based on that you will have application based questions. So you need to know the derivation step by step properly, right? You go through it. If you do not understand, then let me know, then I will do the derivation for you. Okay?
Okay, sir. Practice today.
Okay, ma. Sure. All these things you must learn today itself. Okay? Do not leave it for another day. Okay?
Got it, sir.
Sure. Good. We'll move on. So all this we had discussed last class itself. Okay? Only the applications we had discussed as far as graphs were concerned, which was a homework for you, right? Okay.
Yes.
We were discussing a few questions in the model paper. Now we will, before we discuss the next question. So next question, if you see, is from laws of motion. So these were the questions we discussed.
Yeah.
Next question, the moment we go to next question, it involves force, it involves friction. So we need to give some basics, and then I'll come to this. Okay.
Okay.
We'll just be covering that question, which may not be that helpful for you. Okay, so this steps into the next chapter, which is laws of motion. So of course, there are 3 laws of motion, right? Newton's first law, Newton's second law, Newton's third law, right?
Right.
So what's Newton's first law? Would you need some water? Yeah.
Yes, sir. 2 minutes.
Yeah, sure, please.
Ready, sir.
Number?
Ready, sir.
Yes.
I'll start, sir.
Yes, shall I start?
Okay.
Okay.
So Newton's first law, so it states that if the net external force acting on a body is 0, then acceleration also is 0. But if the net external force acting on the body is not 0, then acceleration also is not 0.
Correct. But what does Newton's first law say? What is the definition?
But it says that every body continues to be in its state of rest or in state of motion unless compelled by some external force to act.
Repeat.
Every body continues to be in its original state of rest or in uniform motion
That word
some
you
straight
used, right?
line
Uniform motion.
along some straight line unless compelled by an external force to act otherwise.
Okay. See here, so point is, a body continues to remain at rest. If it was originally at rest, now also it will be at rest. If it was in uniform motion, what do you mean by uniform motion?
Uniform motion is where velocity is 0, acceleration is 0.
Sorry. Come again. What is uniform motion? Come again. What is uniform motion? You've been learning it. Last 2 classes, tell me, what is uniform motion?
The velocity will not change, it is constant, and acceleration is 0.
That's correct. What did you say? You said velocity is 0. Okay, yes. So velocity is constant and non-zero, of course. And acceleration is 0. Very good. Okay, fine. Unless compelled to change by an external agency called force. Correct. So this is also called as what?
Law,
Yes, tell me. What?
law of inertia.
Okay, fine. And what does inertia depend on? What determines the body's inertia?
Sir is asking you. Yes, I know.
Come on.
Momentum.
Sorry?
Momentum.
Momentum. What is inertia depending on? For a body at rest, is there any momentum?
No.
But you are applying law of inertia to a body at rest also, right? So how is it dependent on momentum? So what is inertia dependent on? Suppose let's say a cat is sleeping next to you. You want to set it up into motion. What do? You give it a hit, correct?
Right.
Apply some force, it starts moving, correct?
Yes.
Now let's say a big elephant is sleeping next to you. Same force will set it up into motion?
No.
No, right? So what is it?
More force to get it moving.
Sorry?
More force to get it moving.
Exactly. So inertia is more for cat or your elephant?
More for an elephant.
Why? So what does inertia depend on?
Force. Amount of force.
Force that you need to apply is a consequence. But why? But inertia is an inherent property of that, right? Force is
Right.
something you are externally applying, correct or not?
Yes.
In order to produce the same acceleration, you're going to apply a greater force on the elephant, correct?
Yeah.
My point is, inertia does not depend on the force, right? Depending on inertia, you apply the force, correct?
Yeah.
What does inertia depend on is my question. Isn't it the mass? Greater the mass, greater the inertia. Is that clear?
Right.
Same is true with a body which is moving with uniform motion, right? Let's say your friend in the college is jogging towards you at a speed of, just get settled so that you can listen to my question.
Answer.
Are you listening?
Yes.
Yeah. So let's say your friend in the college is running towards you with a speed of 20 km/h.
Right.
You want to stop him. You will apply a particular force. Yes, no.
Yes.
Shatabdi Express is traveling and you are on the track. You're trying to do the same stunt. Will it work?
No.
No, why? Same speed, 20 km/h. Why it won't work? Because inertia of the train, Shatabdi train, is much more than your friend.
Greater the mass,
Apply
greater the
much
velocity.
greater force to bring about the same deceleration. Correct.
Right.
You get the point?
Yes.
What does inertia depend on?
Mass.
Yes. Greater the mass, greater the
Inertia.
yes. Good. Okay. What is Newton's second law?
The rate of change of momentum in a body is directly proportional to the force, and it takes place in the direction along which the force acts.
Very good. Can you repeat? You missed one point, one word.
The rate of change of momentum in a body is directly proportional to the applied force, and it takes place in the direction upon which the force acts.
The rate of change of momentum with respect to time. Or you should say that it is time rate change of momentum. So the best way to say is rate of change of
Momentum with respect to time.
yes, yes, that's important.
Excuse me, sir.
Sorry, yeah, tell me.
Sir, but in the textbook it says rate of change of momentum of a body.
It should be either time rate change of momentum or change of momentum with respect to time. Rarely they the moment I say rate of change, they think it is with respect to time, but it is not necessary. Okay. Is it in the NCRT or your reference text?
NCRT, sir.
NCRT? Just
Yes.
yeah, after the class, just send a photo of that.
Sure, sir.
Even if it's NCRT, it is wrong because your force is defined as what?
Mass into acceleration. Or
So that's later. But as a definition,
dp by dt.
yeah. So this must be accounted for.
Oh.
So when I say rate of change, right?
Yeah.
I can say rate of change of momentum with respect to mass,
Mass, sir.
with respect to area. You get my point?
Yes.
So I must be sure that it is rate of change of momentum with respect to
Mass. Time, yeah.
so time. Correct? Okay. Or another way of saying is time rate of change of momentum. Okay. So anyways, that factor time must be in place. Okay. So force is equal to, you can say, or directly proportional to the rate of change of momentum with respect to time. And of course, it acts along the direction of the
Acts along the direction which the force acts.
right. So your momentum is also going to be, the change in momentum is going to happen in the direction of the force. Okay,
Right.
good. So it is equal to F is equal to dP by dt is Newton's second law. You can go further. You know that momentum is what?
D by dt.
Sorry? No, I'm asking you what is momentum.
Oh, sorry.
What is momentum?
mv.
Yes, mass into
Velocity.
Mass is constant, so I can take it out of the differentiation.
Right.
So what is inside?
V.
Yeah. So what is dV by dt? We had learned this from
Acceleration.
acceleration. So that's how it becomes what?
F is equal to ma.
Yes. So it starts with dP by dt.
Right.
Is that clear to you?
Yes, sir.
Yes. When momentum is a constant, your force is zero.
Right.
Why? Because differentiation of a constant is what?
F.
No, what is
The additional constant is 0.
correct? Therefore, if P is constant, then F becomes 0. That's an important point to be. And
Remember.
it comes in handy when we do law of conservation of linear momentum. Okay.
Right.
Of course, a lot of application-based questions will come in the second law.
Okay.
We'll look at a few of them shortly. Newton's third law. What is Newton's third law?
To every action, there is an equal and opposite reaction.
Exactly, right? To every action, there is an equal and opposite reaction. It is also, it is also in a way, it talks about law of conservation of linear momentum. We will understand that. Okay.
Yes.
So let me introduce to you law of conservation of linear momentum. And especially in questions relating to collisions, this will come in very handy.
Okay.
Okay. So when external force is zero, when the net external force is zero acting on a body, the initial momentum equals final momentum. In fact, I can say when next external force equal to zero on a system,
Right.
then the sum of all initial momentums is equal to sum of all final momentum. Momenta, you call it. And you know, momentum is nothing but what? Mass into velocity.
Yeah.
All right. So mi ui is equal to
MFVF.
f refers to the final values. Okay. We'll apply them in problems relating to collisions. Okay. So we'll do a few problems a little later. Okay.
Okay, sir.
So all that you need to understand is when external force acting on the system is zero, momentum is constant. When I say momentum is constant, initial momentum equals final momentum. What does the symbol represent? Summation. There are 103 particles, their individual velocities may change, but overall momentum will remain constant.
Yes, sir.
Now, what are the different types of forces which are in place? What are the different types of forces that you have seen, you've heard of?
Static force is one. Sliding force. Force of
Primarily,
contact.
we have to divide forces, right?
Force of contact.
Sorry?
Force of contact.
There are three types of forces. So one is called as a contact force. Can you give me an example for contact forces? Any idea? What is a contact force?
When if you keep something like a vessel or an object upon a table, so that force is coming in contact with the surface of the table. So that is an example.
What is the name of the force? Name of the contact force? There are two contact forces.
So tell sir then.
One is called friction. The other is called normal reaction.
Did you study all that?
So only friction we did, so we didn't do normal reaction.
100%, 100%. Without that, Newton's laws could not be solved. Okay.
We only did friction, sir. We didn't do normal reaction.
No. In all the problems, if you have done any numerical, I can guarantee you in your notes, you would have at least one numerical where you would have done normal reaction. In fact, even we had in our brief discussion, we had touched upon this.
What, sir?
See here. When you keep a book on a table, the example that you quoted, right?
Yeah.
mg acts downwards, right?
Right.
But something is not allowing the book to fall, right? If mg is acting, then the book should fall down, right?
Yes.
But why is it not happening? Because table is giving an opposing force, correct?
Yeah.
And what is that force called? Either you can call it as N or R, normal force or reaction force or simply normal reaction.
Right.
I'm damn sure you've learned it. Yes or no? You just told me, right? You keep a book on the table. You gave that example.
Yeah, I did.
Yes or no? Only the name is normal reaction. Correct?
Yes.
Isn't it? That means you know it, you have learned it. Correct?
Right.
Yes. Okay. Fine. So now the other force is what?
Friction.
Friction. So important point about normal reaction is that it always acts perpendicular to the surface of contact. So if you see, the surface of contact is along which axis? X-axis, right?
Right.
Where have I drawn the pink line or the purple line? Y-axis, correct?
Perpendicular.
Perpendicular, yes. Always it is, normal reaction is perpendicular to the surface of contact. All right.
Yes, sir.
Okay. Now, coming to friction. Friction is always a horizontal force or a
Correct.
tangential force. Okay. Not necessarily horizontal, tangential force. For example, I have a block. Let's say the surface has friction. I'm trying to move this block by applying a force. Friction opposes the relative motion between the two surfaces. So friction acts tangential. So if I try to move the object to the right, friction acts towards the left,
Yes.
opposing its motion.
Right.
Friction is mainly of two types. Of course, you can also categorize into a third type. Okay. One is called static friction. Another is called kinetic friction. Another is called rolling friction. What do you mean by static friction? Friction which acts when a body is still at rest. For example, let's say you're listening, Samuel?
Yes, sir. Yes, sir.
Yes. So we're talking about static friction now. What is static friction?
It's a friction which acts when body is at rest.
Good,
Still at
good,
rest.
good. Okay. So now what happens is, let's say you have a almirah or let's say a bureau. Now,
Right.
let's say you're taking some effort to push it. Okay.
Right.
Let's say you're applying 5 Newton force and
Right.
the object is not moving. Correct? Why is it not moving?
Because
Yeah, go ahead.
because a lot of force is required to push it, and the person is not applying enough force.
No, I'm asking you why do you need more force? Because somebody is opposing it, right?
Yes.
Who is opposing it? There is nobody on the other side.
Friction.
Yes, friction is opposing it, right? So you're trying to move the object to the right, but friction is acting to the
Left.
correct. So my question to you is this: when you're applying 5 Newton force and you still are not able to move the, let's say an almirah, what is
Yeah.
the frictional force? How much is the frictional force acting? What is the value of the frictional force which is acting?
Double of how much we are applying.
See, if it is double of how much you are applying, right? Suppose you are applying 5 Newton here. Friction is giving you 10 Newton. So what will happen to that almirah?
It will reverse back. It won't move at all.
No, not reverse back. See here.
It won't move at all.
No. Listen. You are applying 5 Newton. You are saying that friction is 10 Newton, correct? Double of what you are applying, correct?
Yes.
If it is double of what you are applying, so you are applying 5 Newton, friction is giving you 10 Newton back, then won't the almirah move towards you back?
Yes.
And you will fall down. Yes or no?
Yes, sir.
So is that what is happening?
No.
No, right? So then friction is not 10 Newton, correct?
Negative. Minus 5 Newton.
Very good. Very good. So how much ever you are applying? So you applied 5 Newton. What is friction?
Negative. Minus 5 Newton.
Meaning to say that it's also 5 Newton, but in the opposite direction, correct? So net force becomes what? What is the net force?
0.
0. That's why the almirah is not moving. Is that clear?
Yes, sir.
Now let's say you drank a protein shake, you became stronger, let's say, or probably you had a spinach like the Popeye.
Okay.
Now you're trying to push it with 10 Newton.
Yeah.
Still your almirah is not moving, let's say.
Okay.
Now why is it not moving? Because of friction. So what is the friction now? How much is the friction?
Minus 10 Newton.
Yes. Correct. So when you applied 5 Newton, it was 5 Newton. When you apply 10 Newton, it is also 10 Newton. Correct.
But in the opposite direction.
That's correct. But it is equal in magnitude to how much you are applying. Correct.
Right.
Suppose you apply 2 Newton, will it move?
No.
Yes. So at that time, what is the friction?
Minus 2 Newton.
So what is static friction called?
Self adjacent friction.
So static friction is called self-adjusting force. Why do you call this? Self-adjusting. Because you applied 1 Newton, it also gave you 1 Newton.
But in the opposite direction.
That's fine. That's fine. What I'm saying is just stick on to the point here. You
Yeah.
applied 1 Newton, that also gave you back 1 Newton. When I say back, it means minus. Okay.
Right.
Okay. When you applied 2 Newton, how much did it give back?
2 Newton.
So when you gave 5 Newton, how much did it give back?
5 Newton.
So what is it? Isn't it adjusting to how much the force is being applied?
Yeah.
So that's why it's called what?
Self-adjusting force.
Correct. Okay. Second point. The maximum value of static friction is called limiting friction.
Can you repeat again, sir?
The maximum value of static friction is called limiting friction. What do I mean by that? Let's say, can you hear me, Simon?
Yes, I can hear.
Yeah. So let's say I apply 12 Newton. Until I apply 12 Newton, the almirah won't move, let's say. Okay. Now let's say you're going to gather enough strength and apply 12 Newton. That's exactly when the almirah will start moving. Got it?
Yes.
Till that point, your force wasn't sufficient for it to move, correct?
Yes.
So that maximum force, maximum value of force that you need to apply in order to bring about a motion in that almirah is called what?
Limiting friction.
Limiting friction. It's nothing but the maximum value of static friction. Is that clear to you?
Yes, sir.
Okay. Now next, we're moving on to kinetic friction. So the moment the almirah starts moving, right, or any body starts moving,
Yeah.
then a different friction acts. Static friction is gone because the almirah is no longer static now.
Yeah.
Now a different friction acts. It's called kinetic friction or dynamic friction.
Right.
Now this friction's value is slightly less than limiting friction. Important to note. The kinetic friction's value is slightly less than the limiting friction value.
Why, sir?
See, if you see, you take more efforts to start moving an almirah from rest to motion, or once it starts moving, it's easier for you to move or tougher to move?
It's easier a little bit.
Yes, easier a little bit, exactly. To get it to start requires more effort than to keep it in motion. Yes or no?
Correct.
Yes. You ask me why, you have to go into what is responsible for the friction, right? So at first
Yes.
level, you can understand it is what? Irregularities in the surface.
Correct.
But if you go much deeper, it is interaction between
Two surfaces.
two surfaces, electromagnetic interaction.
Oh.
All right. So if you see, the moment the body is moving, right, the amount of time that is available for interaction is less.
Yeah.
That's why friction becomes a little less when the body has started moving.
Yeah.
Is that clear?
Yes, sir.
Yeah. So kinetic friction value is slightly less than that of limiting friction. Is that clear?
Yes, sir.
Okay. Now, And it is not self-adjusting force. Kinetic friction is not self-adjusting force. Kinetic friction is standard value, fixed value. It
Yes.
depends on something called as coefficient of friction. And obviously the weight of the body. Greater the weight of the body, greater is going to be the friction.
Done, sir.
Right? And there is a relationship between contact force, the two contact forces, friction, normal reaction. They are related by this equation. F is equal to mu n. Friction is equal to mu times normal reaction. The mu is a
Coefficient.
there is no dimension for mu. Mu is called the coefficient of friction. If we are talking about static friction, then this will be mu s. If it is kinetic friction, then the value will be different. Fk will be equal to mu k times normal reaction. All right.
Yes.
All right. A normal reaction need not always be equal to mg. In this example, which I have told you, normal reaction will be equal to what?
MG.
Mg. Mg acts in the downward direction. Normal reaction is the
Upward
force
direction.
applied by the table on the book or on the mass. Is that clear? That's called normal reaction. And both these values are equal. That's the reason along the y-axis, the box or the book does not move. Correct?
Yes, sir.
All right. Okay, next. Now we move on to the next type of force, which is called non-contact forces. So as I told you, force can be broadly classified as contact forces. In contact forces, what do you have?
Friction and normal reaction.
Correct. Friction is a tangential force.
Yeah.
Normal reaction is a force which acts perpendicular to the contact surface. Is that clear?
Yes.
So we have to graphically represent them. Normal reaction will be on y-axis. Friction will be on x-axis. The resultant of these two forces is your contact force, net contact force. Maybe I can write it as C. So contact force will be equal to friction force plus normal reaction. Vectorial addition.
Yes, sir.
I'm sure you have learned this.
We did, sir.
Fi cap, this notation, right? Nj cap. What is I cap?
I cap stands along the x-axis.
Yeah, I cap refers to unit vector along x-axis, which tells you the direction of x-axis. What is J cap?
Unit vector along y-axis.
Yes. Why did I write like this? Because n is the strength, n is the magnitude of the vector. J cap represents the direction of the vector. Because the moment I say vector, it has two parameters. One is direction, another is magnitude.
Magnitude.
Okay. And of course, the magnitude of the contact force will be given by square root of f square plus n square.
It's good.
You can either go by the right angle triangle Pythagoras theorem, or you can go by parallelogram law of vectors, where you should substitute theta as what? 90, because the angle between normal reaction and friction is 90 degrees. Cos 90 will become 0. Did we not learn that?
Yes, sir.
Yes, we had, right? So the other type of force is called non-contact force. Can you give me an example for a non-contact force? Forces need not act only when there is contact, right? Even without contact, forces can act, right? So could you
Right.
give some examples? Yes.
Something falling from a high surface.
Good, good, very good. So one is magnetic force, right?
Yeah.
So let's say North Pole is here, and South Pole is here. Even at a distance, they will still attract themselves, right?
Yeah.
Or South Pole and South Pole. Even from a distance, they will repel each other. So their
Correct.
forces do not necessarily need to have contact. And what you said, right?
Yeah.
See, probably, you're not touching Earth, surface of Earth. But
Gravity.
even when you're at a distance, right? When you're at a height, right? Probably in the air, still you will experience what?
Gravity.
Gravitational force. So that's also a non-contact force. What else?
Electromagnetic force. Electrostatic force.
Electrostatic force, right? So what is electrostatic force? The force between any two charges, right? So they don't have to touch each other to experience, right? So even at a distance, they will experience the force, right? These are some examples of non-contact forces. Most of these forces we'll be learning only in the 12th standard. Of course, gravitation we learn it this year, correct?
Yes.
But electrostatic force, magnetic force, in depth, it's being learnt in
12th.
12th standard. You've had some intro to all these in 10th standard, correct?
Yes.
Yes. Then forces arising out of connection of bodies through a string. So this a typical example is pulley. Or you're connecting, two objects by a string and pulling them, right? So these are typical, typical questions which are asked in connection of bodies. We will just quickly look at pulley. Before that, I think we can solve one question. I think now you must be ready to solve a question in the CBSE, which was asked, right, in the model paper. We'll discuss that question and then come back, okay?
Okay, sir.
Yeah, let me just. Okay, this is the question, right? So this we have discussed already. Just go through this question now. Give me a second. A force of 49 Newton is just able to move the block of mass 10 kg on a rough horizontal surface. What would be the coefficient of friction? So can you tell me the meaning of, what this might mean? A force of 49 Newton is just able to move a block of mass 10 kg on a rough horizontal surface.
Slightly.
Just able to move. That means, what it means is, we have just, see here, you have just applied that force,
And it is moved.
which is making the almirah to move. Are you able to understand?
Yeah.
So basically, what you have overcome now?
We overcome the friction.
What friction?
Static friction.
Sorry?
Static friction.
Very good. Excellent. So you have overcome the static friction. The peak value of static friction. What is the maximum value of static friction called?
Kinetic friction.
Oh, no. I gave a name, right? Limiting friction.
Limiting friction. Yeah.
Note it down, please.
I didn't know.
Correct. So you are applying, you have just overcome that limiting friction, right? And then the body is able to move now, correct? So let's
Yes.
write the equation here. So you have a surface and then you have a block. What is the mass of the block?
10 kg.
10 kg. Now you have applied a force of 49 Newton, which is just equal to the maximum value of static friction, which I call as limiting friction, which is equal to 49 Newton, right? And we know that the relationship between a friction and normal reaction is. So now what are the forces acting on this 10 kg block in the vertical direction?
Mg.
Mg acts downwards. And what is?
N.
Yes, N is acting in the perpendicular direction, right? And both these values are equal, correct?
Correct.
N is equal to Mg. And we know that friction is equal to what? I told you this, right?
Mu n. Mu n.
To what?
Mu n.
Yes. So now in this, I can substitute. In place of N, what could I substitute?
10 kg.
Mg first.
Mg. 10 into 9.8.
Yes. So mu into 10 kg into 9.8. And what is my static? What is my limiting friction?
49 newtons.
Yes, because that's exactly the force that I'm applying
Correct.
to overcome this, right? So from this expression, I'll be able to calculate what?
Mu.
Yeah. So what do I have? 49 divided by
10 into 9.8.
Sorry, I missed it. Tell me.
98, sir.
Yeah. So 49 divided by 98. What is that?
I'm getting 0.5.
Yes, 0.5 is correct. So did you understand how to solve this, sir?
Yes, sir.
Yes. So this particular question is on friction. Any doubts on this?
No, sir. Clear.
All right. Now we'll just look at pulley, and then I'll also tell you if a question comes in from connection of bodies through a string, how would that be? And also I'll tell you. Then we'll move on.
Okay, sir.
Yeah. Any doubts so far?
No, sir. No, sir.
Okay. Now let's say I have a I give a simple question which is based on, let's say I have 5 kg block connected by a string through to another block which is 10 kg. And let's say I am applying a force of 30 Newton. Okay. Now what will happen is this 30 Newton is applied on the 10 kg block, which is intending to move this to the right, correct?
Correct.
Now for the time being, I'll assume a frictionless surface or a smooth surface. Okay.
Yes.
Now what happens is this 5 kg does not directly experience the 30 Newton, but through this string, which will experience a tension, right? This
Right.
5 kg block will move because of the tension which is here. And because both of them are connected to the same wire or same string, they both will have the same value of acceleration.
Yes,
So
sir.
how do you find acceleration? How do you find this value tension? That could be questions for you, right? So I'll tell you how to find acceleration. So we know that force is equal to what?
Mu n.
Mass into acceleration. So acceleration will be what?
F by m.
Correct? So this I can write it as acceleration is equal to net pulling force divided by the total mass being pulled. So acceleration is given by net pulling force divided by the total mass being pulled. How much is the force you are applying, Samuel?
30 Newton.
30 Newton. So that is your net pulling force. So it is 30 Newton divided by the total mass being pulled. How much is being
15.
pulled?
15.
is being pulled. So 30 divided by 15
2 meter per second square.
meter per second square is going to be your
Answer.
Is that clear to you?
Yes, sir.
So that is the answer for your acceleration. Now I want to find out the value of tension. For that, I can choose any one block, right? Let's say I choose the 10 kg block first. How much is the force I'm applying?
30 Newton.
Right? What is opposing it? Not friction. What is opposing it?
Tension.
Tension is opposing it. Because if this 5 kg block was not there, it will be easier for me to move the 10 kg block, correct?
Yes.
So tension is acting in the opposite direction.
Correct.
Which of these forces is greater? Tell me, 30 Newton or tension?
Tension is greater.
Now, if tension was greater, it would be moving in the opposite direction, right? Which
Right.
direction is the body having acceleration? To the right or to the left?
Right.
Right, correct. So when the body is having acceleration to the right, which force must have been greater, 30 or T?
30.
Correct. Are you understanding?
Right.
Now tell me, 30 Newton and tension, are they supporting each other or opposing each other?
Opposing.
Yes. So it should be 30 minus T or T minus 30. Or should I add them?
Subtract them.
Subtract them, right, to get the net force. So
Yes.
which is greater and how should I subtract? 30 minus T or T minus
30 minus T.
Because 30 is greater, correct?
Yeah.
So this is the net force. Net force according to Newton's law is what? Equal to mass into acceleration. What is mass?
Mass is 5 kg, 10 kg in this
10
case.
kg block we are talking about, right? And what is the acceleration? We just found.
Acceleration is 2.
So 30 minus T is equal to 20. So what will be T equal to?
10.
Yes.
30 minus 20 is just 10.
10 Newton, right? So that's
10.
going to be your answer. Is that clear?
Yes, sir.
The same answer you could have also got it using the 5 kg block. So you can also use this to verify an answer if your answer is correct. Now, what is the acceleration on the 5 kg block?
2 meter per second square.
Yes, both the blocks are accelerated equally. So
Yes.
2 meters per second square. What is responsible for pulling this 5 kg block?
The force 30 Newton.
No.
Tension.
Tension. Is that clear? Is
Yes,
there
sir.
any opposing force to this?
No.
No opposing force. Correct? That's all. So net force is equal to mass into acceleration. So what is the net force, ma?
T.
T. What is the mass?
5.
What is the
into
acceleration?
5 into 2. So just 10. 10 Newton.
Which is same as what we got here too.
Yes.
Is it clear?
Yes, sir.
Yeah, this is one typical, type of question which they can ask you,
Okay.
right? And, which is related to connection of one body with another, right?
Yeah.
Another question that could be asked is pulleys, okay? Let's say I have two masses, M1 and M2. Connected through the same string in a pulley. Let's say the mass M1 is heavier, M1 is greater than M2. Now, if you see, because M1 is greater than M2, what would happen? The mass M1 will go
Down.
The mass M2 will
Up.
Correct. And because they are connected to the same string, they will have the same value for acceleration. They cannot have different values for acceleration. And let's take that there is no friction between the string and the pulley. Okay. In that case, tension on either side will be same. So this portion of the string will have tension T. This portion of the string will also experience the same tension T. Okay.
Yes, sir.
Now the typical question is find the value for find the tension in terms of the masses. Another question is find the acceleration in terms of the masses. For both of them, you need to be well versed with writing Newton's laws. Okay. So how do you do? First is called free body diagram. What is free body diagram? You just take one mass. So let's say you take mass M1. You draw all the forces which are acting on this body. So can you tell me what are the forces acting on this body? M1, M1. What
G
is the
and
force?
N.
Sorry, no?
Then T and N.
T and?
Mg.
Yes, very good. So I'm just drawing it separately. So when I say free body diagram, it means you're forgetting all the other setups. Just you are going to draw that body and its forces. That's called free body diagram.
Right.
So what is acting in the upward direction, Samuel?
T, sir.
T, very good. And what is the direction which M1 is moving? Upwards or downwards?
Downwards.
So answer two questions of mine. M1G and tension, are they supporting each other or opposing each other?
Opposing.
Opposing. So should I add them to get the net force or subtract them?
No, subtract them.
Subtract them, very good. And are they, how are they? M1G is greater or tension is greater? See here, they are opposing is correct. You should subtract is correct. So should you subtract it as T minus M1G or M1G minus T? And why?
M1G minus T.
Greater. Sorry?
M1G minus T.
Why?
Because that is greater than tension.
Why? How do you say that? Because the block is moving down. M1G is acting downwards, right?
Yeah.
If tension was greater, then block, how would it move?
Correct.
Up, correct? So M1G is greater than tension. So it is M1G minus tension. That is the net force. And according to Newton's law, what is net force equal to?
Sir?
According to Newton's second law, what is net force equal to?
0.
Net force is equal to mass into acceleration. What is Newton's second law? Net force acting on a body is equal to?
MA.
Yeah, what is the mass?
M1.
Into acceleration.
E.
This is one equation. Is that clear?
Yes. Yes.
Let me call this as equation 1.
Okay.
Okay. Just give me a second. Stop working. 1. So you got this equation?
Yes, sir.
Let me call this equation 1. Now similarly, can you draw the free body diagram for mass M2? So as far as mass M2 is concerned, could you tell me what are the forces acting on this mass?
M2G and T.
Very good. M2G is acting downwards and tension is acting upwards. Which direction is the net acceleration?
Net acceleration is downward.
Is it downward for M2? Look at it.
Upwards, sorry.
Yes, it is upwards, right? So tell me now, M2G and T, can you write the equation similar to how we wrote for the mass M1? Can you tell me?
So this time T is greater than M2G.
Very good, excellent, excellent. So tell me.
So it will be T minus M2G
Yes,
is equal to M2A.
very good, fantastic. So that's equation 2. So you solve these two equations, you will get the value of acceleration and tension. Is that clear? So that could be a popular question.
Okay, sir.
So let us do that now. So by way of this exercise, you know how to write Newton's equations, right? And solve them. So let me write it here. So the first equation I'm rewriting it. M1G minus T is equal to M1A, right?
Yeah.
What is the second equation?
M2G minus M2G plus T is
Good.
equal to M2A.
M2. Now what do I do to these two equations?
Add them.
Add them, very good. So when I add them, what gets cancelled?
T and T.
Yes, T and this will get cancelled. So what would I get on the left hand side?
M1G plus M2G
No, is it plus? Look at it carefully.
minus M2G.
On the right, what is it?
M1A plus M2A.
Yes. So if I take G outside, what do I have?
M1 minus M2 into G equals to M1 plus M2 into A.
So from this, what is acceleration?
M1 minus M2 into G by M1 plus M2.
Exactly. So this is the expression for acceleration in a pulley. This is one possible question, right? Find the acceleration of the masses in a pulley, correct?
Yes, sir.
What else could be asked? You could be asked tension, correct?
Right.
So let's see that. For that, again, we use the same equations. So what are the two equations? This time I'll write the second equation first. Minus 2 mg plus t is equal to what?
M2A.
And what is another equation?
M1G minus T equals to M1A.
Yeah. In fact, what I could do is I can actually just pick up one equation. That's also fine.
Okay.
Why? Because what is required is just substituting the value of A that I've already got.
Correct.
So in place of A here, what would I substitute?
M1 minus M2 into G by M1 plus M2.
Yes. Correct?
Yes, sir.
So what does this become? So you have here minus M2G plus tension. So tension, you keep it on one side. This minus M2G, you can shift it to this side. So what does this become?
M2G plus M2 into M minus M1 minus M2 into G by M1 plus M2.
Correct?
Yeah. Yes.
So from these two, what would I take common?
M2.
And G also, right?
Yes.
So I can take M2 outside, I can also take G outside. What is remaining?
M1 minus M1 M plus M1 M2. M1 minus M2.
Divided by?
M1 plus M2.
Correct. So when you take LCM, what do you get?
I'm reading the Bible.
So what gets cancelled?
M2 and M2.
Yes. So you'll get M2G into, what is M1 plus M?
2M1 by M1 M2 plus M2.
Yes. So you got the expression for time, tension. Tension is 2 M1 M2G divided by M1 plus M2. This is the expression for tension in the string when you have a pulley with two masses hanging the way it is shown. Is it clear, Samuel?
Yes, sir.
Have you made note of the whole thing?
Yes, sir.
Good. All right. Any doubts in this so far?
No, sir. All clear.
All right. Now we look at the concept in collision, then we can move on. Okay. Whenever collision happens, or probably, let's say a bomb blasts. Now it is all, what is going to be happening is this is because of internal forces. There is no external forces which is going to cause this.
Right.
So, momentum is going to be conserved because in those cases, external force is 0. Therefore, linear momentum is conserved. Here you can have two types of problems. One is problem in one dimension, problem in two dimension. Of course, it comes under laws of motion, but then both problems are given in your NCERT. All right. A simple one which is based on one dimension, and a one which requires vector resolution, which is based on your two dimension. Okay. So today, I think in the next, I think shall we overshoot for about 2-3 minutes? Is that okay?
Okay, sir. No problem.
Yeah. So we will do question on one dimension right now in collision. How would that be? Right. So let me see if I have a question ready for you from my worksheet so that we can take that and discuss it. Just a second.